this first part, these problems look messy to start with. You're actually going to turn them into something that's not that bad to deal with. But a lot of people are intimidated by their first look because they look incredibly complicated, which is actually why we're doing this. This is truly a pre-calculus topic. This is the type of expression you get from some calculus problems, and you have to know how to simplify it. So we're truly going to try to simplify it. Okay. So as I write all this, you may be thinking, whoa, this is a lot. That is 7x. It keeps carrying over. That's 7x squared, yes. Because they turn out this messy.
Hey, is that a squared after the 7x?
That is. That's what you think now. That's why I said it looks intimidating, because it looks like a bazillion quantities. Okay, this is what results from doing a derivative in calculus. Look at my calc students' homework that they're doing right now, and it's exactly what gives you this big mess. Actually, isn't that hard to create the mess? Actually, doing the derivative itself is pretty easy. You guys will learn it next spring. Okay, I want to simplify this, but how on earth do you approach simplifying this? Doesn't mean I want you to start multiplying all this together. That would be nothing more than your worst nightmare. No, you can't cross off. If you all don't mind, let me teach. You're not going to multiply anything.
You're going to factor.
Okay, there's a big subtraction sign here. That matters. You got a subtraction sign in the middle of this. So you can't cancel things unless you can cancel out of every term. We may eventually cancel here. In fact, we will. But
there's a lot of 2x plus 5s and 4x
exactly.
minus 7.
If you look at this is all one chunk, then you have the subtraction sign, and you got all one chunk. What you're looking for is you want to pull out the common factors that you see in both
2x
chunks.
plus 5 and 4x minus
Okay,
7.
you need to do this methodically. Okay? Starting, I usually work left to right. You got a 6. Do you have any just plain numbers over there that would have a common factor? So 6 and 10 would have what number in common? They would both have a 2 in common. So you could say, I'm going to pull a 2 out of here. Then go to the next thing you see. You got a 2x plus 5. And you got one down here. But the question is, which power can you pull out? You always pull out the smaller power, don't you? So we would pull out 2x plus 5 squared. Okay. We'll get to what's left in a sec. Okay. Now, I have a 4x minus 7x squared. Is that repeated? There's supposed to be a power on that. I didn't copy the problem. That is supposed to be a 3/4 on this.
Oh.
Right there's supposed to be a 3/4.
Yeah. One let out. What is negative 1/4?
This should have a 3/4 power on it. Okay. Now, you'll notice that quantity is the same. Which power do you pull out?
1/4.
Which is smaller? Negative 1/4 is smaller, so you're going to pull out the 4x minus 7x squared to the negative 1/4. Negative numbers are smaller than positive numbers. And then 4 minus 7x, is that one in both places? No, so you can't take it out. Okay. These are the terms you're taking out. I recommend a big bracket. Then you go back through and you write down what do we have left after we've taken this stuff out.
3.
Okay, so once again, from left to right, if I took a 2 out, I have a 3 left. I took 2x plus 5, I took 2 of them out. Here I had 3 of them. So there would be 1 2x plus 5 left, would there not?
Yeah, sure.
Okay.
Nothing happens.
Okay, then I took this all to the negative 1/4. That's the exact same thing. I took it all. So that one's completely gone. I took it out.
So you have a 4 minus 7.
And then I have a 4 minus 7x left. Okay. Then a subtraction sign. Now here's the one that gets us.
It's 1/2.
I took out negative 1/4. Okay. Don't you always subtract what you take out? So this is actually the cool part. If I subtract a negative 1/4, which makes it a whole power, they will always turn out to be whole powers. It works that way. So therefore, I will have 4x minus 7x squared to a simple little first power. You don't have to write the power. And then, okay, I can't scroll too far, can I? I took 2 out. So out of the 10, I would have 5 left. And then I took 6 plus 5 squared. I took it clear out front. So it's gone. So I would have, and that's what's left. You're not, okay, how about the bottom? What can I do if I'm a cube 6 squared? Adam says I can multiply. You buy? Yeah. So that's really 2x plus 5 to the 6th.
That's a big power.
Okay. Now we've done the hard part. The rest is a little more cleanup. If you can, now that you have quantities that are multiplied, this is multiplied, this is multiplied, this is multiplied, you can cancel things that are multiplied. So, if I've got 6 plus 5 squared and I've got the 6, what can I do? So that one cancels. I'm taking 2 out, so that becomes a 4th power. Okay, you can also move anything, a quantity that's multiplied with a negative power. Yes, you can move it to the bottom so it becomes a positive power.
So it becomes 4x minus 7.
Yeah, should do that. So, I still want white, dude. It just won't go. So I'm bringing that to the bottom and making it a positive 1/4. So that's gone. So it's 2 times the print within the brackets. You have to simplify the brackets, which you have to FOIL it out and add up like terms. So I'm left with the 2. Okay, you now have to simplify this stuff, which in this case where we got 2 quantities,
Foil.
you got to FOIL it.
Why'd you cross off the 2x squared plus 5 squared?
I took 2 of them. It's the same as this. So I could subtract 2 of them out of 6 and be left with 4 of them. I'm reducing it down. And I took the negative power to the bottom.
Yeah, I knew that.
Okay. So now I'm going to FOIL those. I'm leaving the 3 out front for the time being. So that's going to be 8x minus 14x squared plus 20 minus 35x.
Yeah, these problems get up too much paper.
Okay, now, what do I have to worry about back here? What needs to get multiplied? You have to distribute the 5. You also have to distribute the negative.
Yeah.
So I would just distribute a negative 5.
That's probably smart.
Just treat it like it's a negative 5 and distribute negative 5. So that would make you have a negative 20x and a positive.
Have you done this before? You're pretty good at it.
Never done it before in my life.
You're getting a negative 5.
This might as well doing that, this test is not gonna be very funny for you.
Yeah, this is a killer grade.
Especially when you do as bad as studying. Hey, I bombed one test.
I didn't bump, no, he didn't bump, he like nuclear bonded, we kinda like threw a flat test, like, we bonded.
Okay, so,
What are you gonna do?
now what's left to do?
Nothing.
We're not done, there's still more in the brackets we can do.
Nuh-uh.
I can't see anything.
You just suck.
We gotta distribute the 3 and add up the like terms.
Oh my goodness.
Oh, heavens, distributing 3, really, seriously?
So many trees right now.
Okay. You ain't seen nothing yet.
Just saying, how many pages is this test gonna be?
I think it runs on, there's about 2 problems a page. I'm distributing 3 is all I'm doing. Yeah. That would be an excellent idea. Let's be quiet. All I did is distribute 3. All I did is I multiplied by 3, and then I need to go back and add up all the like terms I've gotten there.
Why is there so much math in this problem? It's too much.
This is like algebra heaven.
I quit.
Okay, generally it's considered good form, particularly when you've got this many terms. We usually go from highest power to lowest power. So, leave the 2 out there, it's adding up the highest powers, which would be the x squareds. Negative 42 plus 35 would give us a negative 7x squared. So, okay, I've done those 2. Then x terms. Yeah, I would buy that. 24, negative 105, negative 20, because that would be a negative 125 back here, plus 24 would be a negative 101x. And then lastly, not least, we got a 60 left.
Wow. I think that's beautiful.
Well, it's as beautiful as you can get.
I mean, when you think about it.
Well, considering where it started, it's still better.
No.
Now,
I quit.
there would be, no, we don't work out the bottom to all those powers. We leave the bottom. There would be, on a rare occasion, an extremely rare chance that you should look at what you have left here and ask yourself if it would factor and cancel with the bottom, but the chances that that will happen are very slim. So we would be done right there, yes. No, they'll leave it out. They won't put it back in. Okay, because then, even though this still doesn't look like a great answer, if we needed to then, in calculus, we would take this and set it equal to 0. Well, okay, at the bottom, when you set it equal to 0, it's only the top that has to equal 0, so we'd only have to solve the top, which would be a quadratic formula. So, it's actually solvable. That's the answer. We're just simplifying it. That's it. We're quitting.
So how do you get it in that algebra form?
In the first place,
You do calculus.
you do a derivative using the quotient rule. April, late April, early May. You're gonna do it. It actually is pretty simple to make it that ugly. It's not hard. It's way easier to do the derivative than it is to simplify it. Doing the derivative is nothing. Yeah.
Where we actually use this in the real world, like.
You don't.
Okay, hold on. Actually, good place to